Yeah, so yesterday we discussed about padding. Basically, padding is an extra space allocated in the memory based on your data type which you defined, and it also depends on your architecture. Okay. So in Postgres, we know this columns order matters a lot, which saves you a lot of space and in terms of performance. Okay. So this has to be designed whenever you are creating a table. So once you created a table, anyhow we cannot change it. So as a DBA, whenever we are doing any deployments, so we can just take care of this part. I mean, whether we can do an order of your tables based on your data types of the columns. Okay. So this is one example which we can recap yesterday what we discussed. So we have a table T1 and we have like 4 columns. So first column data type is int2 and second column is int8, third column is int4 and int8. Okay. The same table I have 4 columns, but the order has changed. So first I'm going from higher to lower as well. Okay. Even you can go from lower to higher. Okay. So definitely if you order from higher to lower or lower to higher, definitely your space will be saved. So we have seen yesterday the length of your data, right? So in this case, for T1, how it allocates in the memory, okay? Since, okay, so integer is here 2 bits. So basically we're talking about bits, zeros and ones, okay? Since the second column data type is 8, it will allocate 8 bits. And if you see here, all the zeros will be waste, which we consider as a padding. Okay, this extra zeros we consider as a padding, extra space in the allocated for this particular data type. And since this is 8, so it allocates 8 and we have 4. Okay, since this data type is 8, it allocates 8 bytes and this extra 4 is wasted. Okay, so for this table totally how many bytes, I mean how many bits has been wasted? Here 6 and here 4, almost 10 bits has been wasted. Okay, but if you arrange the same table in this order, so there is no padding here, right? Because for 8 it allocates 8 and for 4 anyhow we have 8 here, no problem, and for 2 anyhow we have 4, so we don't have any issues in this kind of order. Okay, so even we have seen one example yesterday. If we order the length, so the length of your row will vary. Okay, and even in terms of performance also it will vary. So we'll see one example how it will vary in terms of performance. Okay, so I have so yesterday we have created tables DVD rental pad and DVD pack D, right? And we know how to see this information in the row page, right? So by using this get row page from heap tables, okay, for this pack D table, and we know how to see from pad table. Okay, so this is the difference. Let me fetch like this. So if you fetch for DVD rental pad table, we see the length of the length is 60, right? In the same way, if I check for pack D table, the length is 56. Okay, because the order is different. So if you just recap what we have created, okay, this is the order which we created, right? So for DVD pad, this is the order of your columns, and for DVD pack D, this is the order of your columns. So the order whether you can change from lower to higher or higher to lower. Okay, so definitely this matters a lot. It's good if you change from higher to lower. Definitely you will see much difference. You don't have even much padding. Even in this case, you may see little padding because if you see, if you consider your row header is 24, right? 24 bytes plus this is small int. So for small int, it will allocate 2, right? And again, one more small int plus 2. And this integer, it will allocate 4 plus 4. And one more integer 4 plus, this is a big int. So big int should be 8 plus 8. Okay. So how much total? 52, right? For this particular table we calculated. Um, So if you see how much it got, 56. So even if you arrange this order from uh, lower to higher, you see still 4 padding, right? 52. It should come actual size is 52, right? But here it is 56. Still you could see 4 padding for pack T as well. The same table you can arrange from higher to lower. You don't see any padding even. Okay. So, but if you see this table, the first table, it has 60. Okay. It has 8 padding, but actual should come with 52. So this is how you need to calculate. So this 24 is for row header and followed by your data types. Okay. What type of data type which you define, based on that, it will allocate the space, okay, in the memory. So this is how you can calculate, and you can rearrange from always from higher to lower as per this example. Okay, so in this example, we have C1 for into 2, 8, 4, and 8. Instead of this, you can arrange 8, 8, 4, 2. If you see, there is no extra padding allocated for this in the memory layer. Okay, so whatever data which you are trying to fit, it will be perfectly fit and no extra memory will be allocated. Your performance will be definitely increased. Okay, so let's do an example. Uh, so what I will do, I'm trying to fetch all the records from this table. So this table have the same rows, and even this table should have same rows. We have one more table called DVD pad. Okay, so both the tables having the same records, only the order is different. Now I want to fetch this entire all the records from this table. So for this, I will just take the execution plan. So in the explain, I will also do. Okay, don't worry about these options. We'll discuss in tuning classes. Okay. So for now, I'm trying to take an execution plan for this particular select statement. Okay. So verbose means it will just display the information of this particular query, how much time it has taken and everything. So analyze means it will actually execute your query. So it will execute and it will take the execution plan. If you remove analyze, it won't execute your query. It will just give your plan. Okay. Okay, let me off this so that it's better. Okay. So let me take the same execution plan for this table. Okay. If you see the difference between both the tables, we have same records. I'm trying to fetch select start from DVD rental pack D. From this query, if I take execution plan, so this all columns it is trying to fetch in the filter. We don't have any filter here. It is trying to fetch all the details. And if you see the cost here, 43383, right? And if you see the time taken, okay, execution time taken 531 milliseconds. But for this table, if you see the cost is little high, 45834, and the execution time is also somehow more in terms of milliseconds. So since this is very small table, the small milliseconds doesn't matter, but in real time, okay, in real time your tables will be huge, and the difference will be matter a lot. Okay. So here, if you see both the tables, this is in terms of performance, this table is good because we have some less cost when compared with this, and time also some milliseconds, it is very less when compared with this table. So this table doesn't have proper order, but this table have some proper order, and the row length also 56, and for this it is 60. So that is the reason you could see some difference in terms of performance while reading the data. Okay, so some execution time will be difference for both the tables definitely, and the cost also you could see some difference. Okay. So that is the reason whenever you are designing any table, it's good that you can go from higher data types to lower data types so that you don't have this extra padding, zeros, okay, memory wastage. So this is about padding. And any questions? Yeah. So we also seen like the row header, right? So in the row header, this Infomax is which we are talking. So the last zero, we know that this is representing the null value of your table. If that particular record have any null value in any column, okay? If in any column, if that particular row have any null value, it represents 1, okay? If doesn't have any null value, it represents 0. This is the last 0, okay? And the next 0 is like if you have any variable length of data, okay? It represents, if you don't have any variable length of data, it will represent 0. If you have, it will represent 1. Okay, and the next 0 and the next value represents if you have any CLOP kind of data types. Okay, in Postgres we call it as text. Okay, if you have that text kind of data types, so this will represent whether you have that kind of external storage. Okay, it will represent 1. So like this it will represent, and this 4 bits represent if you are performing any DML operations. Okay, this 4 rows tells us like if the row value or originally it is inserted, or is there any no DML operation performed. Okay, so if you insert, it will have a sort of entry like this. If you do a DML, you could see this changes. Okay, the last 4. So this is how the Infomax value represent based on the data which you have, and based on the data type which you have in that particular column, this Infomax will be represented. Okay, this is about padding. Okay, so if you then we can go and discuss about the toast. Any questions so far? Okay, so let's discuss about the toasting. So this is also one more interesting concept. So basically, toast is nothing but an external table, or we can say another table. If your original record is not able to fit in the page, so basically Postgres will automatically create a toast table, and it's like similarly like you have CLOP, BLOP columns in Oracle, right? So it stores in separate storage, right? So not with your main table. It will store in a separate storage. For BLOP, it will have a separate storage and it will store, right, for CLOP columns. Similarly, if your row is not able to fit in the page, okay, so it will create a separate toast table, and it will divide into multiple chunks in the toast table, and it has a reference from your main table. So that is the main goal of your toast. So internally Postgres have an internal algorithm called toast, heap toast algorithm, heap toast.c, that is an algorithm, so which will create these toast tables based on your data types. Entirely depends on your data types. Okay. So let's understand first some few basics about the toast, and then later we can see what are the toast strategies we have and how internally Postgres algorithm will create this toasting, and it will chunks into multiple chunks. Okay. So the default page size is 8 kilobytes. We know among these 8 kilobytes, we have 24 bytes of your row header followed by row data. Okay. So the main ultimate goal is at least 4 records should fit in the page. So this is a goal. Why? Because we have a threshold in the parameter or in the algorithm called toast tuple threshold. Okay. So toast tuple threshold is 2 kilobytes by default. Okay. So if your row is more than 2 kilobytes, okay, it will automatically create your toast table. So that is the reason the main goal to fit is 4 records, okay, in the 8 KB. So 4 to 8, right? So this is how it works, the algorithm. So the default page size is 8 kilobytes, and there is a threshold called toast tuple threshold. If your row is greater than 2 kilobytes, then it will create a separate toast table, and it will store into multiple chunks. Okay, so why it will create another table called toast and why we need that. Okay, that we'll discuss. That you will understand clearly why we need this toast table. So basically, what happens if your record is not able to fit in your 8K, and it has to again do a page, or we can say row migration, right, or row chaining. So it has in multiple pages. So to avoid that, Postgres doesn't scan multiple pages. Okay, it don't want to scan multiple pages. So that is the reason it will create a separate toast table, okay, based on your data types. So this is the threshold. Okay, by default it's 2K. Okay, and the main goal is we have to fit at least 4 records per page. Okay. So basically, this toast is one of the solution if your row is not able to fit within the page. So it will create a separate toast table, and this toast table will be created based on your data types which you define for your columns. Okay. So we'll see for which data types this toast table will be created, and how, if your row is not able to fit, what is the solution basically Postgres will apply. So basically, as discussed, we have a toasting algorithm. So first what it will do, whenever your page, your row, okay, your record or your tuple is not able to fit in the page, I mean in the 8K page, what it will do, first solution, it will apply the compression. Okay. So if that tuple is compressed and it can able to fit in 8K, well and good. Even though after compression, okay, if your tuple is not able to fit in the 8K, it will create a separate toast table and it will divide into multiple chunks. Okay, so let me share again in the paint to understand better. So basically what happens is, this is my table and this is my toast table. So this table has multiple columns C1 with data type int, and I have data type C2 with text. Text is like your equivalent to CLOB in Oracle. Okay, so the equivalent data type for CLOB in Postgres is text. Okay, and now what happened? I'm trying to fit a row in this particular table. So this is my row. Okay, so any row have your row header and followed by your columns. So this is my int and this is my text. So text, there is no limitation of your size. Okay, text is like unlimited. You can store how much data you want, like CLOB, you can store in the text, right? Even you can store unlimited. Okay, so the data which you are trying to insert is 100, and the text is something, you can say some huge amount of data you are trying to insert. Let's say it's 10 KB, 10 KB of your data in the text column you are trying to insert. So this entire row has to be fit in the table, right? In the page, basically, you can say. So basically, we know the page is 8 kilobytes, and this entire record cannot able to fit in the page because your text data type, your entire row is more than 8 KB. So 10 KB plus, we can say this is some bits, okay? Maybe 4 bits. So more than 10 KB you are trying to fit in the page, okay? So you are trying to fit more than 8 KB of your data, which we can say 10 KB of your data. So this 10 KB is not able to fit in your page. Then what happens is, Postgres internally apply two solutions. First solution is compression. Okay. So first it will try to compress this 10 KB based on the compression algorithm, and it will try to fit. If it's compressed, it may come for 7 KB. Assume it will come 7 KB and it will fit in the page, because in the 8 KB, you can able to fit 7 KB of your data, of your row. Okay. So in this case, there is no problem. But assume that you are trying to insert some maybe 15 KB. Okay. So 15 KB of your row you are trying to fit. After compression, you still think that 15 KB, even though compressed, it is still 10 KB. Even though the first solution applied compression, your 15 KB you are trying to compress, it comes to 10 KB, but still it cannot able to fit in your page. Then the second solution what it applies is toast. So it will create a separate toast table here, and it will create multiple chunks. And so on. Okay, it will create multiple chunks, and it has a pointing from your table, from your main table to toast table like this. You have some sort of pointers here, okay, to read this data whenever it requires, whenever you are trying to select this data, this particular text related or this particular row. Okay, you have a pointer, it will go and read from here. Okay, so this is how it works. So basically this toast table will comes into picture whenever your row cannot able to fit in your page. Okay, within 8K, if it is not able to fit, so your toast table will apply. Okay, the second. First solution, anyhow, it will apply the compression. If your compression is, even though if you do compression, so if your row is not able to fit, then it will create a separate toast table. Okay, and for which data types, basically it will create a toast. And there are some toast strategies. Okay, so based on the data types, we have different strategies that we are going to discuss now. Okay, so we have plain, main, extended, and external. Okay, these are the different strategies we have. Okay, so first let's discuss about the plain. So in the plain strategy, so your data types is, best example for your plain strategies is integer, boolean, and small int. Okay, these are all like small data types. So in this case, you don't need any compression and your toast, because your 8K page can be fit. If you define these data types, if your row have these data types, then you don't need any problem. So your goal will be satisfied. Your 4 records will be fit in the 8K, so no problem. So in this case, there will be no compression and there will be no toast for this kind of data types, especially integer, boolean, and small int. You don't need to worry about it. So in the plain strategy, there is no compression applied, there is no toast table applied. Okay. Now we also have a main strategy. So in the main strategy, what happens? The example for this main strategy data types is numeric and inet. So inet is one more new data type which will be not available in Oracle. So to store your IP addresses, okay, they have defined a separate data type called inet. Okay, so this, whenever you define these data types, inet or numeric, it will by default it will go with main strategy. So in the main strategy, there will be no toast applied, but compression will be applied. Okay, but it's not like every time your compression, even though it applies compression, okay, so we cannot guarantee that the data will be fit. So even though it can apply the toast as well in the main strategy, but most of the cases you don't need the toast in this kind of data types called numeric and inet. Only compression can able to fit your data. Okay. So this is how it applies in the main strategy. So compression will be applied, but no toast table will be applied for numeric and inet. Okay. And we have one more strategy called extended. Okay. So the best examples data types is beta, text, JSON, JSONB. So these are all like big data types, and it's like your CLOB and BLOB. So beta is equivalent to BLOB, CLOB is equivalent to text. And we also have a JSON in Postgres. JSON data type will be supported. Even in Oracle new versions, it is supported, right? So for this kind of data types, since these data types are very big and your row expectation will be more than 8K, okay? In this case, what it applied is, it will apply the compression as well as toast, both, okay, in the extended. Okay, so when you create any table with this kind of data types, algorithm may apply both compression and toast. And there is one more strategy called external. So this external, by default, there is no external. So for any data type, your Postgres will not create external. So this external, as a DBA, we will change few times from extended to external, okay, based on your performance. So in the external, there is no compression, only toast will be applied. So basically this strategy will never be created by default in Postgres. So but this strategy is just available as a DBA, we can change from extended to external based on your performance and some benchmark tests and all. Okay. So by default, it will create with extended, and only difference between extended and external is in extended, it will create both compression and toast, but in external, it will only apply the toast table, but not compression. Okay. So this external Postgres engine will never allocate this external, but it is just available as a DBA if you want to convert your extended data types, I mean, to from extended storage to the external. Okay, so any questions here for this toast?
Suresh, can you explain one more time about the external? Only DBA we will do the external, right? That's what you said, right?
Yeah. So external strategy will be never allocated by Postgres. Only it will allocate extended if your data types is byta, text, JSON, or these data types, right? So few times what happened if you have a text byta data types. So since it is applying compression as well as toast, again in the toast it will divide into multiple chunks. Okay, so few times it may impact your performance when based on your data types, right? If you have these data types, few times you may see this performance ahead. And in this situation, if you don't want to apply compression, anyhow, if it is compressed, the read, so anyhow it will take time, right? Because it is compressed. To read that compressed data, it may take some time than normal plain format, right? So if you don't want to apply compression, you need to manage only with the toast tables. So in this case, you can convert extended with to external. Okay. So by default, Postgres will never allocate external strategy. It will only allocate extended. So this strategy is available just if you don't want to apply extended, you want to convert to external, then you can do that as a DBA. So that we'll discuss here. Okay. So in extended, both compression and toast is possible, but in external, only toast is possible. And by default, only extended will be allocated by Postgres engine for this kind of data types. And sometimes few people will override it from extended to external by using this command. Okay. So this is just to take an advantage that you don't want a compression. I only want toast. So in terms of performance, it will improve your performance, right? So, but again, you simply should not change this, right? So you have to do some benchmark tests and some analysis, then only you have to do. So this, you usually will never change this, right, in real time. So alter table name, alter column. For this column, you are setting the storage as an external, okay, from extended. So you have to do some benchmark test analysis, then only you have to change. So otherwise so without doing any benchmark and thing, we should not change from extended to external. Okay, but we have an option to change this from extended to external. Okay, and internally toast algorithm will have a compression algorithm. So we know for the first solution it will do a compression. So by default we have PGLZ algorithm. Okay, so this algorithm by default Postgres will use. Okay, so apart from this PGLZ, we also have LZ4. So there is one more algorithm called LZ4. So in terms of performance, that LZ4 is better than this PGLZ. Okay, if you see here, this is the performance stats. There is a company called Fujitsu where they have did some analysis, and this is the graph. Okay, in terms of performance, if you see here, without uncompressed, okay, without uncompressed, you see this is the performance, and with this PZLZ algorithm, so in terms of performance, if you see the graph is high, right? But if you see LZ4, it is almost equivalent to uncompressed data, right? Which means for plain data. Even though it is compressed, but in terms of performance, it is giving equivalent like your uncompressed data. So this LZ4, right? So, but by default, Postgres engine will use this PZLZ algorithm. But we also have one more algorithm called LZ4. Okay, this algorithm is so better. I mean, in terms of performance, it is so better than PGLZ algorithm. Okay, even you can change your compression algorithm by setting this to LZ4 algorithm. Okay, so any questions so far? So we'll see practically to understand better. If you don't have any questions.
Yeah, one question, please.
Yeah.
So in the diagram that you had, I think you mentioned if the row does not fit, let's say if initial size is 15K and even after applying compression, let's say it is 10K, it won't fit into a 8KB page.
Yeah.
In that case, it would share a pointer to the toast table, right?
Yes.
So that means it would fit 8KB into that original page and 2KB into next page, and that is where the pointer would be, or what?
No. The entire row will be fit in the toast table in terms of multiple chunks. Okay. It is just a pointer that in this page, okay, this record is pointing to this toast table. Only that pointer, that's it. But your entire data will be fit in the toast table only.
Okay, thank you.
Yeah, into multiple chunks. Okay, so now what we can do, we can just try to create few table, maybe create table T1, or maybe I will do PG plain. So here I'm just creating with two columns, one with the integer data type, and I'm going to create one more column with Boolean. Okay. Now, if I want to see which toast strategy it applied for this table, okay, here you have given data type int and Boolean. So basically for these data types, as per this toast algorithm, so for as per this toast algorithm, okay, for the data types int and Boolean and small int, you don't need any compression and you don't need any toast. Okay, so let's see what toast strategy it will apply. So if you give /t plus, okay, it will give much information about your columns and your data. If you see the storage, it has allocated as a plain. Okay, so it has used the plain strategy. Here you don't need any compression and you don't need any toast because your data can able to fit for these data types into your page. Right, and we can also see whether it has any rows in the toast table for this. Okay, let's see. We have pg underscore class. Okay, so here relation toast. Let me connect in. Let me change it to regular class. So this is my relation name. If you see, there is no toast table created for this, right? And if your data type is text or byte, okay, you could see the toast table will be created for this kind of data type. So for now, there is no toast table applied, and we see the strategy is plain. So now what I will do, I will just try to create one more table. Okay, so create table. I will give PG main for this table. And here I will go with numeric data type. And I will also go with one more data type called INET. Okay, so maybe I will store my IPs INET. INET is one of the data type to store your IP addresses. Okay. Now let's see what strategy it used for this table. Okay. So whenever your data type is numeric or INET, it will go with main. So in the main, it will use the compression, right? So, but few times it may also use yeah, so few times it may also use the toast. Okay, it is not like every time it will go only with compression based on your data which you are trying to pick. It may also go with toast. Okay, let's see whether it has created any toast table for this table. PG main. Okay, so here it has created a toast table, but now anyhow I don't have any records. Okay, so it may use or it may not use. Okay, that is the reason it will just create a toast. If the compression is not able to fit, then it will use this toast table. Okay, for this particular table, PG main. Okay, and we will see next. Okay, after creating this multiple data types. Okay, we can also see to insert some data into the table, and we'll see when this toast table will be applicable. Okay, so for now we just remember based on the data types it is creating with this strategies. Okay, now let me create one more table. Okay, so for that table probably I will create with text or okay, let me create one more table with a mixed with main and plain. Okay, mixed data types. We'll see what it happened. Now I will give PG plain main. Okay, I'm creating with the mixed data types here. So for ID, I will do a numeric, and for maybe I will give IP address also in this for INET, and I will give state as Boolean. Let's see what. So if you see, it is whatever the data types which is applicable for main, it take the main, and for plain, it has taken the plain. Okay, for Boolean. So even though if you create like this, okay, based on your data type only, it will allocate the store strategy. Now, if you see whether this particular table have toast, it will just create a toast table, okay, but it has created a toast table. If compression may not help, then it will use this table. Now, let's go and create one example for extended strategy. Okay, so I'm trying to create a table, PG. So here I will use ID int and info text. Let's see what strategy it used. Okay, if you see for ID it used the plain, and for info, since it is a text data type, it used the extended toast strategy. Okay, for this definitely you could see a toast table, right? Because we may expect if the data type is text, okay, so compression and toast both has to be applied, right? So now what I will do, I will try to insert few data into this table. Okay, so in the PG extended table, so what I will do, insert into values. So what I will try to do is I will use a function called repeat just to repeatedly insert that particular data. Okay, so repeat. Okay, I want to store some a value. 10 times. Okay. Yeah, bucket is first. So if you see, I've inserted one record with value A, it will repeat 10 times. Okay. So this is my actual data in this table. Okay. And now what I will try to do is I will try to find out my actual length of my table, like on this column, and how the storage size it has fit in the memory. Okay. So I have a query. Let me take that query. This table and order by. So basically what this query is telling, so I'm trying to find out my actual length of my data and the storage length. Okay, what how much KBs it is trying to store. Okay, so here almost it is equivalent, right? Because I don't need, for this kind of data, I don't need any, even I can see the toast table count, okay, whether it has used or not. Because my data is able to fit, right? So I don't need to use this toast table, right? So there is no data, even though my data type is extended. Okay, I have inserted only one record with this much size, and this data, this record is able to fit in my page. So that is the reason, even it is not applied any compression, right? If you see, the actual length and storage length is both almost equivalent. Okay, and even the toast is also not applied, compression is also not applied, because it is able to fit without compression and without toast this much of data, it is able to fit in my page. Okay, now what I will do, I will try to insert maybe 1,000 times. Okay, okay, so 1,000 times I have inserted, and second record will be 1,000. Now let's run the same query. So here, if you see, the actual length and the storage length is almost same. So even it will not use the toast table as well, right? So here the toast table is also 0, and it can able to fit the 2 KB of your data into into your page. Now let me try to insert one more. Let's see. There is no toast applied, and let's go and see the size. Okay, so if you see here, for this particular, so now we have inserted 10,000. So for 10,000, it is compressed. Now if you see, if you observe the difference, it is compressed to 125. Okay, even though you have this, you have actual length is 10,000, it is storing with 125. Okay, and let's see whether the toast table is using. No, there is no toast table. Still your data is fitting in the page. It is not moving to your toast. Okay, and you could see here it is compressed here, right? And now what I will do, maybe I will try to insert, instead of 100, I will do 300 here or 200, and I will try to insert 5 lakhs. Now we'll see how it is storing. So for this, okay, it has compressed this much, and we'll see whether the toast table is used. So if you see, now the toast table is used, right? So it is divided into a number of things, and it is stored in the toast tables. Okay, now your page data, this particular record, okay, it is not able to fit in your page. It has done a compression and it used the toast table. So both compression and toast is used in this case. Okay, and now what I will try to do is, okay, let me try to delete from equal to, I will use 3 times, so everything will go away, no problem. So I've deleted this, and let me try to insert. Here I will try to give 400, and maybe I will just insert some bigger number. Okay, it's almost near to 2 KB, right? So this value is almost near to 2 KB, and we'll see if toast. Since we already have this record, okay, and this much data which we have inserted, and it is not able to fit, it also use the toast and compression both, right? So this is how internally the toast algorithm will apply. Okay, based on your data types, it will create a toast table and it will try to compress first. If it is not able, even though compression, if it is not able, it will use this toast table. Okay. So any questions so far here? And if you want to know what types of data types I have in my, so based on your storage type, okay, if you want to know, see, I have tell like for plain, okay, so I have in Boolean small int. Okay, for main, I have numeric and inet. And for extended, I have byte, text, and JSON, and so on. But still, there are so many data types which is supported in Postgres. If you want to know which data type comes under which type of storage strategy, okay? If you want to know, we have a view called PG underscore type. Okay, so in this, we have type name. Okay, let's try to do a PG type where um, descriptively type name, yeah, type storage. Okay, so let's do PG underscore type where storage equal to, maybe if I want to know main, then just use small m. Okay, so these are the data types come under main strategy. And if you want to know for plain, okay, so for plain, if you see these all data types will come under the plain strategy. Okay, so inet 8, name, varchar, boolean, int2. So these are all, there are so many data types. Okay, timestamp, date, this all will come under which strategy? Plain strategy. Okay, and even let's check for E. Okay, E, I don't know which type of presentation. Let me try to fetch. Or maybe X. Okay, it is representing its X, not extended. So for extended, if you see byte, text, and these are all like system related. Okay, don't worry about this type of. We have JSON, XML. Okay, and we have VPChar, varchar, bit, varchar bit. So JSON B. Okay, these all types of record. Okay, so these all types of data types will come under extended, right? So based on this PG underscore type, you can able to find which data types comes under which type of a storage type. Okay, so you can just go and see from this particular view PG underscore type. So we have X, M, and P. Okay, P means plain, M means main, and X means extended. And if you want to know, and if you are good in the C language, and if you want to know how the toast works, okay, so let's go and see the source code where it looks like. We have here in the bin folder. See, not here. Source home. Okay, so actually I don't have the source code. Let me go and download the source code so that it's better to understand the algorithm. Okay, so postgresql.org. In the source code, you could able to see billing. I'm trying to download my source code, okay? And this location, wget. So I'll try to, since it's taking time, I'll try to copy from my local machine. Okay, I'm copying from my local mission to here because it's taking time to. Okay. I just want to show you the source code, like how the algorithm works. Okay, I have copied it to my. Okay, so now this is my source code. Okay, so I'm trying to unzip this code. Okay, so here, this is my source code, right? So in the source code, there is a folder called source. If you go in the source, we have backend. Okay, there is a folder called backend. In the backend, we have access. In the access, we have heap. Okay, in the heap, so we have a algorithm called heaptoast.c. So this is the algorithm which they are using for. Okay, so here if you are good in the C, you can just go and see so exactly how it is applying this algorithm. So based on the data types what you define. Okay, here they will mention some rules. Okay, how exactly this toast will be applicable. Okay, so based on your data types, if you see here they are taking some condition for int and for boolean. So if you are so based on your data types, they are going to define how this will work. Okay, so you can just go and see this algorithm, how it works, and you will understand. Even they will mention like easily all the comments. Okay, so you can just go and read at least these comments. You will understand what this loop is doing. Different kinds of condition based on your data length. Okay. Yeah, so this is about the toast. And do you have any questions so far? Okay, so that's it we have for today. Probably from next session, we will discuss about the backups.
Yeah, there is a user management also.
Oh,
Right.
yeah.
We'll start with that. Guys, these are the internals, okay? So the internals of the pages, okay? These things will be very much helpful to you, like whenever if you start working on some tuning related concept, okay? So this is for our like better in-depth understanding, okay? So yeah, we can jump into like a user management from next classes. Okay, so these things very, very useful in our real-time systems, guys.
Okay, if no one has any questions, then we can drop off today and we can catch up tomorrow for the other topics. Okay, yeah, thank you.